Okay, this is a calculator active polar question. So I would go ahead and at least put these equations into your graphing calculator in polar form just to look at it. But notice you only need to look at this graph from 0 to pi. So if you're not sure which graph is which, r equals 3 is a circle. So it's really this half circle that they're showing. And then this one, this is this graph right here. So if you want to just make sure you know which one is which. Okay, it says let R be the shaded region that is inside the graph of R equals 3 and inside of the graph the other one. Find the area of the shaded region R. Okay, first of all, when you look at the shaded region R, notice that from here to here, it's only shaded by the green graph. So really, in order to find this region, I only need to integrate the green. And then notice this portion is only shaded by the purple graph. So I only need that. Okay, so that's a clue, first of all, that you will need two separate intervals because I've got two different graphs that I'm looking at. Okay, I'm going to do this purple region first. There's a couple ways you can do it, but I do notice it is a quarter circle. So I'm just going to do it geometrically. So it's pi, r is 3, r squared, and it's a quarter circle, so it's pi r squared over 4. So that's that purple one. Okay, now the green one, which is this one, you're going to need to find the bounds. So you can trace this out on your calculator, okay? This has to be theta equals 0, and really, if they're telling you this is graph from 0 to pi, if you look at this graph, you'll notice it goes this direction. So since this has to be pi, this has to be pi halves, and if you're not sure, you can check on the calculator. So my bounds are going to be from 0 to pi halves, and remember, area of a polar is 1/2 r squared, and the only r I'm looking at is this equation, which is 3 minus 2 sine 2 theta, d theta. So there's my setup, and then if you punch this on your calculator, this is what I get for the entire area. Okay, next part. Part B says, for the curve, the green curve, find the value of dx d theta. So remember, anytime they talk about x's and thetas, we're talking about in polar, we need an equation that connects the two. So this is my equation, x equals r cosine theta. And then really, there's my r, so if I plug that in, I have this. Okay, now, so I need some form of this, and then we are going to go ahead and take the derivative on the calculator. So at this point, we are not looking at the picture anymore, so you can just type this into your y equals screen. This would be your y equals, your theta is your variable. So have the calculator take the derivative of this and plug in pi over 6, and you should get negative 2.366025 for that derivative. Okay. Next says the distance between the two curves changes for 0 to pi halves. So that means from 0 to pi halves, I'm only looking at this portion, right? This is the 0 to pi halves. So the distance between the two curves is changing. Yes, I can see that. Find the rate at which the distance between the two curves is changing. So I need to find the derivative at which the distance between the two curves. So I need to figure out an equation for the distance between the two curves. Distance is just, if you think about in polar, remember your r variable is the distance from the origin. So the distance between the two curves would just be the difference in your r coordinate at any particular point. And notice if you are in quadrant 1, and you always want your distance to be positive, notice it's always the purple graph minus the green graph. So your distance would just be 3, the purple graph, minus the green graph. So this is an equation for the distance. I can clean this up pretty easily. The 3's will drop out. So this is my distance equation. So I have the distance between the two curves. I want the rate. So the rate is another word for derivative. So I'm taking this derivative. It just happens the letter I use is d. So the derivative of d with respect to theta, you can take this derivative pretty easily by hand and plug in the pi thirds, or you can use your calculator, but you're going to get negative 2 regardless. Okay. Lastly, a particle moves along the curve so that d theta dt equals 3. Find the value of dr dt. So remember, always look at what are you given, what are you trying to get to. I need dr dt, The only thing I'm given is d theta dt. So think about what else do I need. Notice that the dt has to stay, but I really need the d thetas to cancel, so I need a piece with a d theta on the bottom, and then I need dr on the top, so I really need that. So in order to find dr dt, d theta dt is 3, but somehow I need dr d theta. Well, the equation we're talking about is this equation. That's an equation that relates r's and theta, so you can use your calculator to find this derivative at pi 6, and if you do that, you end up with -2, so this is going to be -6.